Hello everyone, my name is Dan the Tutor, and welcome to Lesson 4 of the Algebra 1 summer course. Today we have a very important lesson. It's adding and multiplying fractions. If I were to tell you that this was the second most important lesson of the 8 weeks, and that's because the first most important lesson would be factoring, and that's just because you're going to be using it all the time when it comes to Algebra 1, and throughout your algebra and calculus and pre-calculus and Algebra 2 careers. But when it comes to adding and multiplying fractions, this is a fundamental skill. If you're not good at it, you are going to be sorry later on. And believe me, because I constantly ridicule my high school and college students for not knowing how to add and multiply fractions. It is such a fundamental skill. I cannot stress enough how important it is to know it. So the first thing I wanted to tell you is that we do not write mixed numbers anymore once we get to Algebra 1. It's very rare that you would write a mixed number like 3 1/2. Instead, we're going to prefer improper fractions, which just looks like this, 7/2. I couldn't tell you exactly why we don't like it, but I'll tell you, for me personally, 3 1/2 does not work very well with many of the operations we have in math, while 7/2 is going to be very friendly to work with the notation that we're going to be using. So even if you disagree with me, I don't care. We're doing improper fractions today. Which then begs the question, what if I give you a mixed number? How could you convert that to a complex fraction? In other words, how do I get from 3 1/2 and turn that into 7/2? And here's how we're going to do it. So basically, all you need to do is you need to say 3 times 2, in other words, the whole number times the denominator, and then you're going to add the numerator. So in other words, it's 3 times 2 and then plus 1. And 3 times 2 is 6. 6 plus 1 is 7. That's how you get the 7. And then all you need to do is put that over the same denominator we had earlier, which is 2. So just to repeat one more time, all you need to do is multiply the whole number by the denominator, and then you add the numerator. We got 7, and then you put it over the original denominator, which is 2. In case you need more practice with that, we have 4 great examples of that right here, which we will do right now. So first, for 2 1/4, I'm going to say 2 times 1/4, or really 2 times 4, and then plus 1, because that's the numerator. So 2 times 4 is 8. 8 plus 1 is 9. Again, that's my numerator. And what was the original denominator? That was 4. So the final answer is 9/4, just like that. Now for the next one, we have 6 3/5. Again, same idea. Do the whole number times the denominator, so 6 times 5, and then you add the numerator, plus 3. So then we have 6 times 5 plus 3, that's 30 plus 3, which would give us 33. And again, we have to write it as a fraction, so 33/5, because 5 was the original denominator. Why don't you give the next two a try on your own, pause the video, or if you're watching live, we'll give you some time, and then we'll reconvene in about a minute. Okay, and that should be enough time for us to now go back over it. And so for the first one, we have 10 7/8. What I'm going to do is 10 times 8, so 10 times 8, plus the numerator, which is 7. So that's going to be 10 times 8 is 80, plus 7, that's 87. And again, you need to put it over your denominator, which is 8 for this problem. And that's the answer, 87/8. And then for the last one here, 15 2/3. That's going to be, again, 15 times 3. So 15 times 3, and then plus the numerator, plus 2. 15 times 3, maybe you don't know that. Maybe you need a calculator. But I'll tell you, it's 45 plus 2, which will be 47. And again, you just put that over the original denominator of 3. And there's our answer. And that's how we're going to change mixed numbers and turn them into improper fractions. Now, once you have them as improper fractions, now we can actually talk about adding and subtracting fractions. So let's fill in the blanks. Before you add or subtract fractions, you need a common denominator. We're going to need a common denominator. And a common denominator is basically having the same denominator. For instance, if I have 3/5 plus 5/4, I cannot add these two things together because these denominators are not the same. So that's what we're talking about when we say common denominators. Now, next fill in the blank. Let's say you get the common denominator, which we'll be showing you how to do that in a moment. But let's say you want to add fractions, you would need to add the numerators and keep the denominators the same. That's how we're going to add and subtract fractions. Well, I guess the next fill in the blank. When you subtract fractions, you subtract the numerators and you keep the denominators the same. So same idea for adding and subtracting. All you're doing is the math in the numerators while you're keeping the denominators the same. So as an example, let's say we have 3/4 plus 5/4. Well, if we have 3/4 plus 5/4, then all you're going to do is you're going to add the numerators. 3 plus 5 is 8. And then keep the denominator the same. Keep it as 4. And then you always want to ask yourself, can you reduce? Can you reduce? What does reducing mean? Well, 8 over 4, 8 divided by 4, hopefully you know what that is. The answer is 2. And if you didn't know that, another thing you could say is both of these things are divisible by 4. In other words, 8 divided by 4 is 2, 4 divided by 4 is 1. So in other words, you really have 2 over 1, which is the same thing as 2. I'm going to be training you on how to reduce fractions throughout today, so don't worry if you're not good at it yet, we're going to get better. And then the same idea when you subtract fractions. So with 3/4 minus 5/4, I'm going to subtract my numerators while keeping my denominator the same. Don't touch the denominator. So then 3 minus 5 is -2 divided by 4. Both of these things are divisible by 2. Like for instance, -2 divided by 2 is -1. 4 divided by 2 is +2. It looks like the final answer is -1/2, and you can't reduce any more than that. Any questions so far? Okay, good. Now for the next one. The next few are going to be some easy ones, and then I'll teach you how to do the harder ones. So for 6 over 7 plus 1 over 7, again, we add the numerators together, keep the denominators the same. It looks like we get 7 over 7, which hopefully you know, that's just going to be 1, because 7 over 7 is 1. Now for the next one, 5/11 minus 4/11. I subtract the numerators, keep the denominators the same. It looks like I get 1 over 11 this time, and this one cannot be reduced, because 1 is not divisible by 11, and therefore you're done. Like there's nothing else to reduce here, and that's completely fine. This is the best answer. You don't always have to reduce, but you should always try and look and see if you can reduce, because that's important. And now earlier, I said that we need common denominators when the denominators are different. So let's fill in the blank here. If the denominators are different, we need to make a common denominator. And now I'm going to teach you how to find that. This is the hard part. This is the part where most students give up, unfortunately. But you won't, because you're my students. And we do this by multiplying the fractions by the least common multiple. And I'll explain what this is in a second, okay? First I'll give you a second to write that down. But the least common multiple is basically this idea. Let's say I want to find the least common multiple between two numbers, let's say 3 and 7. The way I would do that is I would write out the multiples of 3 and then 7. So for instance, with 3, I have 3, then 6, then 9, then 12, then 15, then 18, then 21. Now why did I stop at 21? Well, because 3 times 7 is 21, so it wouldn't make any sense to go beyond that. Now let's do the same thing for 7. You start with 7, you go to 14, and then you go to 21. And as you can see, this is the only number they have in common. There's no other numbers in common here. So in other words, the least common multiple, I'm going to call it the LCM for short, least common multiple, is 21. Now that's the worst case scenario. The worst case scenario is that you just multiply the numbers together. 3 times 7 is 21. Let me show you another one that will be better for least common multiple. Let's say I have 4 and 6. Now I know 4 times 6 is 24, so I'm going to stop at 24 for both of these. So 4 will be 4, then 8, then 12, then 16, then 20, then 24. And then for 6, I have 6, then 12, then 18, and then 24. Now as we can see, 24 is definitely in common, but this one also has 12 in common. So the least common multiple, least common multiple, is the 12 because 12 is the smallest number. And basically what that means is that when you're getting a common denominator, you should choose 12 and not 24 because it's going to be easier on the math for us. Also, there's probably going to be less reducing later on. So that's one of the concepts we're doing here when it comes to adding and subtracting fractions. Now let's look at some examples and see what we do. We have 1/2 plus 2/3. What's the least common multiple of our denominators, which our denominators are 2 and 3? Well, 2 times 3 is 6. And I have a feeling that I'm not going to have any common numbers before that. The reason why is because I have 2, then 4, then 6 for the 2's. And then for the 3's, I have 3, then 6. In other words, the least common multiple is definitely 6, so that's what I'm going to use. Now, here's the hard part. You have to ask yourself, 1/2 times what gets me 6? And that's actually not a hard question, in my opinion, because the answer is multiplying by 3. However, you need to multiply by 3 over 3. You have to put the numerator and denominator the same number. There is a technical reason for that. I'm not going to explain it right now. But all I'm saying is you have to multiply by 3 over 3 in the numerator and the denominator. And then plus, for 2/3, what am I multiplying that one by? Well, I'm going to multiply that one by 2 because that's what I need to multiply by to get my denominator to be 6. So now let's do this. 1/2 times 3 over 3. I kind of did this backwards actually. So in the next section of this lesson, we're going to talk about multiplying fractions. I just realized that we're doing multiplying fractions first, and that's okay. So all you need to do to multiply fractions is multiply the numerators and denominators separately. In other words, 1 times 3 is 3, divided by 2 times 3 is 6, plus 2 times 2 is 4, divided by 3 times 2 is 6. Now let's take a moment to pause and see what we did here, okay? First of all, we have 6 in the denominator. Now I can add these fractions together. This is really good. And so 3 plus 4 is 7. Keep the denominator the same. This is going to be the final answer. But what did we do to get here in the first place? Remember, I found the least common multiple is 6. How did I know it was 6? Because 2 times 3, the denominator's right here, is 6. And there's no other least common multiple other than 6. Then I had to play the game, what do I multiply each fraction by to get 6 in the denominator? For 1/2, I had to multiply by 3 over 3 to get 6. And for the second fraction, I had to multiply 2 over 2 to get 6. And that's what we did. Now, even if this is confusing, we're going to be doing a ton of examples today, so you're going to get it by the end. Let's look at another example. 1/2 and 3/4. I don't even care if it's plus or minus. In this case, it's minus. The first step doesn't change. The first step is, what is the least common multiple? And the answer is 4. Why is it 4? Because even though 2 times 4 is 8, we know that 2 times 2 is 4, and then they'll have the same denominator. So I know the least common multiple is 4, and let's go ahead and try and adapt the fractions in order to get that common denominator. Here's what I mean. We take 1/2, we multiply by what to get 4 in the denominator? Well, we need to multiply by a 2 to get that to be 4. And in the numerator, it's also going to be 2 because, again, the numerator and denominator has to be the same. So it looks like we have 1/2 times 2 over 2. And then minus 3/4 times what? Well, this is great because we already have 4 in the denominator. Don't change it. Don't change it. Don't multiply by anything. Okay, we're happy right now. And now I'm going to multiply the first fractions together. 1/2 times 2 over 2. Again, numerators separately. 1 times 2 is 2. Denominator, 2 times 2 is 4. And then minus 3/4. And then now they have the same denominator. This is great because now I can just say it's 2 minus 3 over 4. And that's going to be a final answer of negative 1/4. And that's how we do it. So now for the examples coming up, we're going to be doing the exact same thing. We have 6 examples that we're going to do, and I'm just going to do the exact same thing we've been doing. Okay, so first one, 2/5 plus 1/3. First, I need to figure out what the least common multiple is. Well, 5 times 3 is 15, and I have a feeling that there's going to be no least common multiple, and the reason why I say that is because for 5, you have 5, 10, 15. For 3, you have 3, 6, 9, 12, 15. 15 is the least common multiple. It's the only one they both have in common. So now I have to multiply 2/5 by what to get a common denominator of 15? Well, I need to multiply by 3 over 3. Why? Because the denominator's 5 times 3 gets me that 15. And then why is the numerator 3? Because the numerator has to be the same as the denominator. Okay, now maybe you can figure out the next one for yourself. Plus 1/3 times what gets me 15 in the denominator? It's 5 over 5. Because the 5 has to go in the denominator, because 3 times 5 is 15, and the numerator has to match the denominator. And now all we need to do is multiply the fractions together. So for instance, 2 times 3 is 6, 5 times 3 is 15. Again, I just multiplied numerators and denominators separately. And then plus 1 times 5 is 5, divided by 3 times 5 is 15. And that's going to give me a final answer of 11 over 15. Hopefully you're starting to get better at this. Now for the next one, we have 9 and 4. By the way, here's how I know that none of these are going to work in terms of the least common multiple, except for 9 times 4 equals 36. So up until this point, I've had a very good idea of what the least common multiple is. Here's how you know if there's going to be a least common multiple less than 9 times 4. And what do I mean less than 9 times 4? I'm saying if we go back to the other page I was doing, remember how 4 and 6, 4 times 6 is 24, but 12 was the least common multiple? Yeah, the reason why that happened is because they have a common factor. What do I mean? What are the factors of 4? You have 2 and 2, right? And what are the factors of 6? You have 2 and 3. In other words, they both have a 2 in it. That's how I knew there was going to be a less number than 24 as the least common multiple, because they're both divisible by 2. Now, going back here, what do 9 and 4 have in common? Well, 9 is 3 and 3, and 4 is 2 and 2. They don't have anything in common, right? So in other words, I know automatically 36 will be the least common multiple, and that's okay. So now what I'm going to say is 7 over 9 times blank equals 36. The answer is 4. 4 over 4 specifically. And then for the other one, minus 1/4, it's going to be 1/4 times what equals 36? And the answer is 9 over 9. That will get me 36 in the denominator. So again, now I just have to simplify. 7 times 4 is 28, divided by 9 times 4 is 36. And then minus 1 times 9 is 9, and 4 times 9 is 36. So you have 28 minus 9 is 19, and then keep the denominators the same. It looks like our answer is 19 over 36, and this cannot be reduced. This cannot be reduced. Okay, here's the next one. For this next one, I'm going to show you what happens if you do it the wrong way. What do I mean by the wrong way? I'll tell you. So with number 3, you should recognize, hopefully, that the least common multiple is not 12 times 4 equals 48. It's not this. It's actually just 12. And the reason why I know that is because the factors of 4 are 4, 8, and 12. And immediately I have the least common multiple as 12. But let's say worst case scenario, you don't see that and you use 48 instead. Let's see what happens when you do that and you miss the goal. As it turns out, it's going to be kind of annoying, but that's okay. So what we're going to do for this one, the long way, and that's fine. You can do it the short way after this on your own if you want. But it's going to be 5/12 times what equals 48? The answer is 4 over 4. And then plus 3/4 times what equals 48? Well, 4 times 12 equals 48. So that's what's going to be times. So that's going to be 20 over 48 plus, and the reason why it's 20 over 48 is because 5 times 4 is 20, 12 times 4 is 48, plus 3 times 12 is 36 over 48, and that's going to give us an answer of 56 over 48, which is not our final answer because that can be reduced. Let me prove it. Right now we have 56 over 48. Both of these are divisible by 2. 56 over 2 is going to be 28, and 48 divided by 2 is going to be 24. So this is a more reduced answer. However, we can keep going because 28 is divisible by 2, and so is 24. 28 divided by 2 is 14. 24 divided by 2 is 12. That's a better answer. But now we can do it even one more time because 14 divided by 2 and 12 is also divisible by 2. And so we're going to get a final answer of 7 over 6. And that's what happens if you don't get the least common multiple. You'll still get the right answer, but it takes a longer time because there's a lot of reducing that you need to do. And that's never fun. Any questions on any of the ones we've done so far? No? Okay, so now let's continue with number 4. Number 4, 1 over 6 minus 3 over 2. Same idea here. The least common multiple is going to be what? It's not 6 times 2, it's not 12. The least common multiple is actually 6 because 2 times 3 gets me 6. So what that means is for the first fraction, 1 over 6, I do not change it. I already have my denominator I want, which is 1/6. And then minus 3 over 2 times, to get 6 in the denominator, need to multiply the denominator by 3, which means a 3 will also go in the numerator. So it looks like the answer is 1 over 6 minus 3 times 3 is 9, 2 times 3 is 6. Okay, we're at a good start. And then 1 minus 9 is going to be negative 8 over 6, which again reduces because these are both divisible by 2. Negative 8 divided by 2 is negative 4, and 6 divided by 2 is 3. So the final answer is negative 4/3. You'll notice for this one, even though we got the least common multiple, we still had to reduce. And that happens sometimes, and that's perfectly fine because we know how to reduce fractions, hopefully. Maybe you don't know as well as me, but at least I can help today. Okay, now the next one, 13 over 6 and 5 over 4. We talked about this least common multiple already. If you do out the numbers, you'll see that 12 is the least common multiple because 6 times 2 is 12 and 4 times 3 is 12. So with that, we do the same thing. 13 over 6 times 2 over 2 will get me a 12 in the denominator. And then minus 5 over 4 times 3 over 3 will get me a 12 in the denominator. So it looks like 13 times 2 is 26 over 12 because 13 times 2 is 26. And then 6 times 2 is 12. And then minus 5 times 3 is 15. And 4 times 3 is 12. Now, numerator's 26 minus 15 is 11 divided by 12. That cannot reduce. Our final answer is 11 over 12. And then for the last addition and subtraction one for today, we have 4 over 9 plus 5 over 6. This one's hard in terms of figuring out the least common multiple. So again, I'm going to help us by listing out the multiples. For 9, I have 9, 18, 27, 36, 45, 54. And I stop at 54 because 9 times 6 equals 54. Okay, now I just have to list out 6 until I have a number in common. So for instance, 6, 12, 18, stop. Why stop? Because we just found our least common multiple. I can keep going if I want. I can say 24, 30, 36, there's another multiple, but the least common multiple is going to be 18. 18. And that's going to make my life a lot easier, believe me. So the least common multiple is 18. So now I'm going to say 4 over 9 times what gets me 18? It's going to be 2 over 2. And then plus 5 over 6 times what gets me 18? That's going to be 3 over 3. So then 4 times 2 is 8 over 18 plus 5 times 3 is 15 over 18. 8 plus 15 is 23 divided by 18. Does that reduce? Well, let's see. Are there any factors of 23? Is 23 divisible by 3? The answer is no. It's not divisible by anything. So this is our final answer, 23 over 18. Hopefully that made sense. And now with multiplying fractions, we're basically going to do what we've already done today. Just multiply the numerators and denominators separately. But what you're going to see is that we're actually going to make it more challenging, and you'll see why in a second. So first, with 3 times 5 and 2 times 7, hopefully you know this already because we've been doing it so many times. 3 times 5 is 15, 2 times 7 is 14. There's your answer. No work more needed than that. But now, why we're even going over this in such detail is because we want to reduce fractions before multiplying if possible. Keep in mind, well actually, I'm going to jump the gun. Let me scratch that from the record. Let's do this first example, and then I want to warn you of something that could go horribly wrong if you don't listen to my advice. So with that being said, we have 5/4 times 2 over 25. always try to reduce fractions before you multiply. I see two fractions that can reduce. See the 5 and the 25 here? Both of them are divisible by 5. Like 5 divided by 5 is 1, and 25 divided by 5 is 5. Similarly, 2 and the 4 can also reduce. 2 divided by 2 is 1, and 4 divided by 2 is 2. Now let me write this out again with what's left after I cross things out. In the numerator, I have 1 times 1. In the denominator, I have 2 times 5. And this is really easy, because 1 times 1 is 1, 2 times 5 is 10. There's our answer. If you do not do this strategy, if you do not try and reduce, here's what happens. Because we had 5 times 2 over 4 times 25, right? That's going to be 10 over 4 times 25 is 100. And then you have to reduce now at this step, which both of these are divisible by 10. So you'll get 1/10 that way. Some of you may be thinking, hey, this was easier than the other way of doing it. But trust me, reducing first is the better way, especially for more difficult problems where it's not so easy to simplify. And you'll see what I mean. So let's see number 1. 1/6 times 3/10. Does anything reduce here? Yes, it does. The 3 and the 6. So 3 divided by 3 is 1. 6 divided by 3 is 2. So basically in the numerator, we're left with 1 times 1. And in the denominator, we're left with 2 times 10. So that's going to be numerator 1, denominator 2 times 10, 20. There's our answer. Now for the next one, 9/4 times 3/5. Does anything reduce for this one? The answer is no. Why not? Because do not try and simplify the 9 and the 3 because they're both in the numerator. You can only simplify if something's in the numerator and the denominator. That's the only way it can cancel. So in other words, there is no reducing possible for this one, which means you're just going to multiply across. In other words, 9 times 3 is 27. 4 times 5 is 20. That does not reduce. We're done. You don't always have to reduce, but you should always look for reducing before multiplying. Always look first. Next, number 3. 8/3 times 1/4. We have here, again, 8 and 4 are both divisible by 4. So 8 divided by 4 is 2. 4 divided by 4 is 1. Looks like we're going to get numerator, 2 times 1. Denominator, 3 times 1. This is easy. It's 2/3. So there's our answer for that one. And then for the last one, for this page, we still have a couple more on the next page. But for this last one on this page, we have 2/6 over 3/2. I see that there's a couple ways you can actually do this one with the reducing. I'll do it this way. I'm going to say 2 divided by 2 is 1 here and 1 here. These are both divisible by 3. So 1 here and 6 divided by 3 is 2. So it looks like I have 1 times 1 over 2 times 1, which is just going to be 1 over 2, 1/2, final answer. Now, one thing I want to warn you about, and this is super, super, super important because it directly contradicts everything we just did with the multiplying by fractions. Let me show you what I mean. Let's say I have 1/4 plus 3/8, something like this. And this goes back to, oh, this is adding fractions. I need a common denominator. I'm probably going to multiply the 1 over 4 by 2 over 2 because that gets me the common denominator of 8. And I don't have to change the 3 over 8 because it's already 8 in the denominator. I'm happy. But then you have 2 over 8 plus 3 over 8, right? The worst thing you could do right now, is say, hey, I learned from multiplying fractions, you should always reduce first. And you say, hey, 2 divided by 8, that's going to be 1 over 4. And now it's 1/4 plus 3 over 8. Guess what just happened? You just undid the work you did to get the common denominator. So now you'd have to do it again, and you're just wasting time. And definitely don't do this. So when we're adding and multiplying fractions, do not reduce before you add. The whole reason is you want the common denominator right here at this step because now you can add the fractions together and you get 5 over 8. And then if you want to reduce after that, that's fine, but don't reduce until you add them together. Remember, that is completely the opposite of what I'm telling you right now with this multiplying fractions, because multiplying fractions, the very first thing I'm telling you to do is to reduce first. So just keep that in mind. I know it's confusing. If you want to rewatch this lesson, do the problems again, You'll get it better the second time. I think that's a good idea. If not, the homework has a ton of good examples for you, and I'll let you do those. Now with number 5 and number 6, you're going to see these problems are the reason why we simplify first. Because even if you know what 12 times 4 is, you probably don't know what 16 times 21 is without using a calculator. So this is why it's so important that we reduce the fractions. Now let's ask ourselves, do these things have anything in common? Well, I know 4 and 16, they're both divisible by 4. So 4 divided by 4 is 1, 16 divided by 4 is 4, so we got that one taken care of. Now 12 and 21, do they have anything in common? Yes, they do. They're both divisible by 3. So 12 divided by 3 is 4, and 21 divided by 3 is 7. So now what we have here is 4 times 1 over 4 times 7. As a matter of fact, maybe you notice the 4's here will cancel as well, and that is true, they do cancel. And so the answer is just 1/7, just like that. Pretty easy. So that's it for number 5. Any questions? And then the last one here, number 6. We have 18 over 10 times 100 over 24. We need to do the exact same thing. So hopefully you see this. 100 is divisible by 10, so it's 10. So 100 over 10 is 10. 10 over 10 is 1. And then for 18 over 24, what do they both have in common? You can say 2, that's one answer. You can say 3, that's another answer. The best answer is they both have 6 in common. So 6 is going to save us the most work. So because they're both divisible by 6, 18 divided by 6 is 3. 24 divided by 6 is 4. It looks like we have 3 times 10 over 1 times 4. And again, you can multiply these together if you want, or you can try and simplify one more time, because they do simplify. In other words, 10 and 4 are both divisible by 2. So that means that 10 over 2 is 5, and 4 over 2 is 2. So now we're left with 3 times 5 over 1 times 2. And then the final answer is 15 over 2. And that's the best answer. Now, hypothetically, you don't have to do that second reduce. That was optional, I'll admit. What would you do then if you didn't do the second reduce? You'd have 3 times 10 over 1 times 4. You'd get 3 times 10 is 30 over 1 times 4 is 4. These are both divisible by 2, so you'd get 15 over 2 anyway. It's just another way of doing it. I don't care which way you do, but definitely try reducing first. That's what I'm forcing you to do. And that's it for that. The last thing we're going to talk about today is dividing fractions, which is often scary, but it's really not that bad, because the secret to dividing fractions, if you want to divide fractions, just flip the second fraction and multiply. That's all you have to do. Let's look at an example. 1/2 divided by 3 over 2. Here's what I'm going to do. Here's the second fraction, flip it. So what I'm saying is 1/2 multiplied by flip 3/2, that's 2 over 3. Okay? That's what we mean. That's the secret to dividing fractions. You flip the second and multiply. Another word for flipping, by the way, it's called the reciprocal. If you've ever heard of that before, that's what that is. Flipping is just the reciprocal. That's the math term for it. Now, anyways, you'll see that these 2's will cancel right here. So the answer is just 1/3. That's it for the first one. Now let's just finish up with the last 3 here, and then you can have a great rest of your 4th of July. So you have 3 over 7 divided by 2 over 5. Again, I'm going to flip the second and multiply. So it's going to be 3 over 7 times 5 over 2. Notice here, nothing cancels, even if you wanted it to. So you just multiply across. 3 times 5 is 15. 7 times 2 is 14. That is going to be our final answer for that one. Now for the last 2, why don't you go ahead and try these on your own. If you're watching the recording, pause the video, and you can unpause it when you're done for the last 2. Okay, I'm going to assume we're done now. So we have 11 over 3 divided by 22 over 6. So that's going to be 11 over 3 times 6 over 22. Again, we're flipping. Now 11 over 22, hopefully you see they're both divisible by 11. 11 over 11 is 1. 22 over 11 is 2. And then same story with 6 and 3. 6 divided by 3 is 2. 3 divided by 3 is 1. It looks like this is going to be 1 times 2 over 1 times 2. Even the 2's cancel. And it looks like you just get 1 as your final answer. That's it for number 3. And then for number 4, the last one, 8/5 divided by 1 over 9. It's going to be 8/5 times 9 over 1. Does anything reduce here? The answer is no. So it looks like the final answer is 8 times 9 to 72 divided by 5 times 1 is 5. There's our final answer, and that's it for today. So if you don't have any more questions, you're free to go. Thank you all for watching and listening. My name is Dan the Tutor. Hope you have a great rest of your 4th of July, and until then, I will see you next week. Bye-bye, bye-bye, bye-bye.